Cadence, NVIDIA upgraded silicon power modeling for big AI chips. Developed in a joint effort with NVIDIA, Cadence Dynamic Power Analysis DPA tools will assist engineers in creating more energy efficient hardware. What do wrong is why the predicting power behavior is getting harder for AI chips. Dynamic power analysis, closing the pre versus post silicon gap. The massive complexity and computational needs of today's most advanced AI chips pose a big challenge for designers. They are often unable to accurately predict their power consumption under realistic conditions. To address that, the Cadence introduced a dynamic power analysis DPA tool that enables more precise power analysis of high-performance chips, particularly GPUs and other big AI chips, before the physical silicon is ready. Cadence said the DPA app developed through a close collaboration with NVIDIA runs on top of each Palladium G3 hardware emulation platform to evaluate the dynamic power consumption of chip designs with billions of gates, and the DPA can handle billions of cycles in hours instead of days with up to 97% accuracy. The EDA giant said the innovation allows chip designers and system designers to address power issues before fabrication the final chip, resulting in more efficient hardware while accelerating time to market. The NVIDIA VP of Hardware Engineering Narendra Konda said by combining the NVIDIA's accelerated computing expertise and with the Cadence EDA leadership, we are advancing the hardware accelerated power profiling to enable more precise efficiency and accelerated computing platforms. While predicting power behavior is getting harder for AI chips, the collaboration comes as the latest AI training chips become increasingly power hungry. These chips can contain 100 billion or more transistors based on advanced nodes like 4 nanometer or 3 nanometer. While these transistors each sacrifice a relatively small amount of the current during operation, the power quickly adds up. And although the supply voltage of the transistors is as low as 0.7 volt, the chips can burn through more than 1000 ampere or even 1500 ampere of current, putting continuous power, also called thermal design power or TDP, at over 1000 watt. High-performance GPUs such as NVIDIA's Blackwell B100 and B200 consumes as much as 1200 watt to take care of the computationally intense jobs such as AI training and, a lesser extent, inferencing. So things are trending up with the NVIDIA's next generation Rubin GPU, which is estimated to consume the 700 watt per 3 nanometer accelerator die. The multi-die Rubin GPU could use 1800 watt when surrounded by the high bandwidth memory HBM. The Rubin Ultra, which will double the number of chiplets, could have a TDP of 3600 watt. Cadence is primarily known for its electronic design automation (EDA) tools, which are employed by the companies such as AMD, Apple, Intel, and NVIDIA to aid in the development of next chips. But it's also a hardware vendor, supplying platforms such as Palladium that can emulate these designs and enable engineers to see how they perform and how much power they draw while running a real workload. By enabling the pre-silicon verification and validation, and hardware emulation helps the companies to deliver product to market at a faster pace than Cadence. According to NVIDIA, it used these tools for pre-silicon verification and validation of its Blackwell family of the AI chips, and the company is utilizing the latest generation and the Palladium G3 for some of its future processor designs like Rubin. In the context of the pre-silicon verification and validation, having timely and accurate power estimation for actual workloads enables engineers to redesign or re-optimize the hardware software to strike the best balance of the power and performance, said Michael Young, director of the product marketing at Cadence. But accurately projecting the power consumption of AI chips such as the Blackwell is becoming more difficult. Technically, this is due to the challenges of the modeling power as smaller transistors are packed more closely. These ultra-dense chip designs make it inherently harder to predict power underlying under dynamic conditions. In addition, AI workloads have a highly variable power characteristics straining different parts of the chip at different times. Given that it's important to emulate the entire chip over as many cycles as possible. There are also pretty practical reasons. Under tightened deadlines, engineers rarely have time to perform the full chip dynamic power analysis across billions of cycles. That frequently leads to a discrepancies between the pre-silicon and post-silicon power dissipation. Dynamic power analysis, closing the pre and versus post-silicon gap. Traditional power analysis tools struggle to scale up to more than several hundred thousand cycles without requiring practical amounts of time, according to the Cadence. In the past, users could do small slices of power estimation windows in hundreds of thousands of cycles, which limited the power profiling view and hence the accuracy of the real power used to process a particular workload, noted Young. The company worked closely with NVIDIA to overcome these challenges, so using hardware-assisted power acceleration and parallel processing innovation to enable more fine-grained power analysis on Palladium. We now have the ability to measure the power estimation on real workloads at a length with billions of cycles instead of a few thousand cycles, which was a practical limitation in the past due to the time it takes to process, said Young. He added that DPA can more accurately estimate power consumption on the real-world workloads, allowing the power and performance to be verified before being locked into silicon. When the chip design can still be optimized, particularly useful for power-hungry GPUs and other AI accelerators, the early power modeling helps to improve efficiency while preventing delays that comes from over-designing or under-designing them. In the context of polysilicon validation, engineers can gain very accurate power data, stated Young. This allows engineers to rethink what could be optimized while silicon design is still in the pre-silicon stage. It is also integrated into Cadence analysis and implementation solutions so that designers can do power estimation, reduction, and sign-off throughout the design process, giving you more energy efficient and easier to cool silicon. As data centers blow through even more electricity, accurately predicting chip level power consumption is becoming a bigger deal, while power densities at the server level are pushing to more than a 3 kilowatt. Rack level requirements are also scaling rapidly from 30 to 40 kilowatt today to more than 120 kilowatt for a single rack equipped with the NVIDIA's Grace Blackwell superchips. Underestimating power doesn't just risk inefficiency, it could also lead to overloaded power supply or cause thermal failures in other parts. With the advanced AI ML type of design, the need to fully emulate the entire silicon design with the realistic ML workloads is at the heart of the system validation, said Young. Palladium DPA adds the extra power dimension to the functional validation by evaluating the hardware and software at the same time and factoring them both into power profile. Palladium gives engineers more accurate models of silicon validation. Okay, see the next article. The industry. Unlocking the industry articles. The unlocking the power of digital twins in ASICs with the adaptable eFPGA hardware is meant from Mentor. Adaptability is essential for digital twin systems due to the constantly evolving environment. Learn how eFPGA hardware enables robust and adaptable systems by Mentor. What are digital twin systems and why are they so important? Digital twin systems are crucial for industrial applications because they create real-time, data-driven virtual models of the physical assets, processes, or systems. This enables companies to optimize performance, predict and prevent failure through the predictive maintenance and stimulate data design changes without the need for costly physical prototypes. By providing continuous monitoring and analytics, the digital twins improve decision-making, enhance operational efficiency, and increase the system resilience. They also support safety and regulatory compliance by allowing engineers to model hazardous scenarios and validate responses virtually. Ultimately, digital twins empower industries such as manufacturing, energy, automotive, aerospace, and industrial automation to operate more intelligently, efficiently, and safely. Benefit of the digital twin system description. Operational optimization. Continuously monitor and improve the performance by identifying the inefficiencies in real time. And predictive maintenance. Forecast equipment failure or schedule maintenance before breakdowns, reducing downtime. Faster innovation. Simulate design changes and system configurations virtually, reduce the need for physical prototypes. Improve the decision making. To use real-time analytics and modeling to make smarter operational and strategic decisions. Enhance safety and compliance. Model hazardous scenarios and validate safety responses to meet the regulatory standards. Create resilience. Increase agility and system resilience through the real-time visibility and predictive insights. Why is adaptability important for digital twin systems? Adaptability is essential for digital twin systems in applications because these environments are constantly evolving with ongoing changes in equipment and processes, workload, and operating conditions. An adaptable digital twin can adapt to these changes in real time, supporting dynamic operation without a need for the complete system overall. Next one is China mandated the domestic firms to source 50% of the chips from Chinese producers. Beijing continues to squeeze the companies over reliance on foreign semiconductors. Questions remains about how native chips will work with the existing AI infrastructure and software performance platforms like CUDA. China has mandated that all domestic data centers begin using more Chinese-produced processors, a part of an increasing initiative to make China self-sufficient when it comes to silicon. As reported by SCMP, this comes at a time of enormous global investment in data centers, AI and processor production, with an increased drive towards self-efficiency and nationalistic stances on cutting-edge technology. Moving forward, publicly owned Chinese data center firms will reportedly be required to source more than 50% of their chips from domestic producers, according to people said to be familiar with the matter. This comes from the guideline initially published last March by the Shanghai municipality. And this order appears to have now been extended to the wider country and could have a large impact on China's chip adoption and investment, as well as the country's overall interest in U.S. processors. Major U.S. companies like NVIDIA and AMD have faced federal holders to head selling their latest chips to Chinese firms to some time and are currently only able to sell watered down the version of their latest designs as or while giving the US government a 50% cut of any proceeds and terms of the latest White House deal, although it seems that the US government does want to maintain a favorable trading relationship with China and its domestic companies, and the process has been fraught with the turbulence in recent months, raising concern that a company unable to source the chips that are needed to would turn to other avenues to acquire them. They're related to smuggling, but also may be part of the drive toward more local chip production in China. Like NVIDIA and other US company initiative to spend hundreds of billions of dollars in data centers construction and US-based chip fabrication, China has also announced a plethora of the new data center projects in the past few years. Many of these were expected to be powered by some version of the latest GPUs and NVIDIA and similar companies. However, the amidst again trade blockades and Chinese concerns over tracking hardware built in to the graphic card as looking to drive more investment into locally produced chip moving forward. The news powers reported last week and China was discouraging the use of a product like NVIDIA's H1212, hinting at a security concern. The reason of this policy may be the slowdown in China's AI innovation, though, while locally produced chips are said to be capable enough for AI inference, the day-to-day operation of running the AIs, they aren't as capable as the latest NVIDIA's and AMD GPUs for training. Limited access to the latest design and any future designs going forward could severely limit China's innovation in this space. Its domestically produced GPUs are considered years behind the likes of NVIDIA's latest development. Notably, the DeepSeek R2 was recently reported to have run into delays after it was trained on hardware chips rather than NVIDIA hardware at the behest of the Beijing. There's also the question of what software such Chinese chips might run on, and how that might work in conjunction with used American processors. The video chips can leverage the powerful and near ubiquitous CUDA ecosystem, which China's produced chips will not be able to take advantage of. Okay, next one is AMD post record $7.685 billion revenue despite massive inventory charge, $800 million MI308 write-off, not enough for stock biggest ever quarter. Best quarter ever. The AMD on Tuesday published its financial result for the second quarter of its fiscal 2025, posting revenue of the $7.685 billion, which is the highest quarter revenue ever. The company's results were driven by a significant uptick in the client CPU sales and strong sales of data center processors, but at the same time the company results were partially offset by the $800 billion hit from the Instinct MI308 GPU export restrictions to China. AMD's revenue for Q4 FY 2025 reached to $7.685 billion, making a 32% of year-over-year and a 3% quarter-over-quarter QQ increase. The company's net income totaled $872 million, up to 129% compared to the same quarter a year ago, and 23% sequentially. However, a sequence of the $800 billion write-off, AMD's gross margin dropped over 40%, down from the 49% YOY and from the 50% QOQ, We delivered strong revenue growth in the second quarter, led by the record server and PC processor sales, said Dr. Lisa Su, and Chair and CEO. We are seeing the robust demand across our computing and AI product portfolio and are well positioned to deliver significant growth in the second half of the year, driven by the ramp of our AMD Instinct MI3050 series accelerators and 350 series and accelerators, and ongoing the EPYC and the Ryzen processor share again. Strong results across all product segments. In Q2 2025, and the client and gaming division achieved a record $3.621 billion in revenue, making a massive 69% year-over-year increase and significantly contributing to company's overall growth. The client segment and alone with $2.5 billion in revenue, driven by the strong demand for AMD's latest Ryzen processors based on the Gen 5 microarchitecture and richer product mix. The gaming segment also saw a 73% revenue increase compared to the same quarter of 2024, reaching $1.12 billion. This growth was fueled by the higher shipment of the semi-custom SoCs used in the game console with strong demand for Radeon RX 9000 series GPU for gamers and AI applications. Combined factors like flavor of superior product mix, increased demand for graphic cards, and rising demand for console processor led to sharp YoY rise in operating income for a division of 362% year-over-year to $767 million. As for the AMD Data Center lead division, it generated $3.24 billion in revenue, growing 14% year-over-year despite significant headwinds. The growth was primarily driven by a strong demand for AMD EPYC CPUs and AMD gained shared across both cloud and enterprise market. However, the division profitability was severely impacted by $800 million in inventory and related charges due to the U.S. export restriction on the distinction MI308 as an accelerator, resulting in operating loss of the $155 million compared to the $743 million in income a year ago. Excluding this charge, the business would have remained profitable, and AMD's division posted revenue of the $824 million, down 4% YoY and flat sequentially. This decline was attributed to the mixed demand across the end market and the macroeconomic softness and variability in customer ordering patterns, according to the company. Operating income for the embedded against the segment was $375 billion, a 20% decrease compared to the same quarter last year. Optimism forecast. For Q3 2025, we expect a revenue of approximately $8.7 billion plus minus $300 million, representing around 28% year-over-year and 13% sequential growth at the midpoint, and another record quarter of AMD. This outlook reflects strong demand for AMD's accelerator as companies expect its Instinct MI350 series to ramp in Q3. EPYC server processors client produced due to the start of the back-to-the-school season and stockpiling for the upcoming Christmas season, though it excluded any potential revenue from the Instinct MI308 GPU shipment to China. As the expert license application remains under U.S. government review, while Q3 is traditionally good for the AMD's gaming segment, as console makers Microsoft and Sony increase purchases of the SoCs for their products. This time around, AMD expects flattish revenue. Okay, next one. UCIe 3.0 doubles data rate 4D chiplet. The UCI consortium released the 3.0 version of which uses an open standard designed for high speed and interoperability operable connectivity between the chiplet in the same package. The new version of the standard is fully backward compatible with the earlier version. UCI chair Devendra Das Sharma told Times, "We want to make sure that things move in a backward compatible manner so people's investment are protected." Das Sharma said, "We needed to deliver the best power and performance and cost metric data people can get, and then of course we have to continuously innovate. The key to the making sure that a standard keeps getting deployed is to continuously innovate." Headlines and communication speed for planner communication via UCIe S2D and UCIe 2.5D has delivered 48 and 64 giga transaction per second respectively. A lot of hungry application primarily in the space, but also in HPC and in other areas, and short lines limited. The Sharma said, "Whatever short line you have fixed by the side, we need to deliver more the benefit, and the way to do that is to double the data rate." As a result of the change of the bit era, PER for the 64 giga transaction 2 mode was reduced from the 1 power minus 15 to 1 power minus 12. That Sharma said that it is the problem as external interconnect like PCIe and USB and use 10 minus 12 or 10 minus 10 power minus 6 with poor data operation. This add-on needed to be used to increase the data rate. At the request of DSP providers, support for continuous transmission protocols has been added to the new version of the specification. The goal is to enable the uninterrupted data flow between the SoC and the DSP, split in the wireless infrastructure radio and radar system. The issue has been a mismatch between the ADC frequencies and link frequencies and the previously required for synchronized PLS, which could introduce noise into a noise-sensitive circuit. The new version of UCI maps ADC and MTS transmission protocols only existing the raw mode and align links to operate at the same daylight as data generation. In its runtime recalibration and L2 state, the deep power saving state helps save power. Other features that help with the manager come from download across multiple chiplet and the new function to prioritize transmission of the low latency messages over the sideband and features to help in the event that an emergency throttle and shutdown is needed. Thus, Sharma said the new feature for the standard and prioritized them based on a combination of how straightforward they are implemented and how useful they would be. UCI is the preferred standard for chiplet file source synopsis. Something have a longer lead time, of course, so of course we are working on them, but some things may not be ready for prime time, he said. Even if a feature misses a major release, we will keep it in the bucket. That's the nature of the beast. Some are harder to tackle and some are easier from a time perspective. Ultimately, it is a democratic process, Sharma said. In the end, it depends on how much bandwidth people are willing to spend and how many review cycles are going to happen, he said. The standard is tied to any particular release cadence. That Sharma said, rather the release cadence reflects the demand for member companies. Okay, today, thank you for your time. See you next time.